Analyzing a circuit with a single resistor is easy. Ohm's law makes the relationship between the voltage, current, and resistance of that resistor very straightforward. Things start to get a bit trickier though when we combine multiple resistors and other components together in complex arrangements. The simplest way that resistors can be connected to each other is in series. Resistors connected in series are attached to each other end to end. In this arrangement, the combined total resistance of the series of resistors is equal to the sum of all of their individual resistances. We can treat this collection of resistors in series as a single resistor with a larger resistance value. One reason for combining multiple resistors in series is to create a resistor value that you cannot otherwise have available. For example, if I needed a 3 kilo ohm resistor for my circuit, but all I had in my box of parts were 1 kilo ohm resistors, I could combine 3 of them in series to make a 3 kilo ohm resistor. This resulting 3 kilo ohm resistor will have the same tolerance as the individual 3 resistors used to create it. So if each of the 1 kilo ohm resistors that I use have a tolerance of plus or minus 5%, which means their actual resistance should be somewhere between 950 and 1500 ohms, the combined resistance of the 3 resistors in series should be anywhere between 2850 ohms, if they're all on the low end, up to 3150 ohms. That range is a 5% tolerance around the resulting 3 kilo ohm resistance. The power rating of the resistors combined in series will be limited by what each of the individual resistors can handle. The weakest link in the chain of resistors will determine their limit. In this example, each of the 3 resistors have the same resistance and they will each have the same current passing through them since they're arranged in series. Therefore, they will each be dissipating the same amount of power. We can calculate the power that will be dissipated by each resistor using the equation that power equals current through the resistor squared times its resistance. This equation comes from some clever rearranging of Ohm's law. If I attached this series of resistors to a circuit that produced 20 milliamps of current through them, the power dissipated by each resistor would be 20 milliamps squared times 1 kilo ohm, which is 0.4 watts. If I built this circuit using resistors that were rated to handle half a watt, this would work fine. Each of the resistors will dissipate less than half a watt, which would be their maximum power rating. But things get a little trickier if you start combining multiple resistors in series that have different resistor values. For example, if instead of using 3 equal resistors, I used 2 500 ohm resistors and 1 2 kilo ohm resistor in series, the power equation shows that the power dissipated by each of the 500 ohm resistors will only be 0.2 watts. If I was using half watt resistors to build my circuit like before, both of those 500 ohm resistors would be fine. They're well under their power limit. However, the power dissipated by the larger 2 kilo ohm resistor with 20 milliamps passing through it will be 0.8 watts. That exceeds the half watt power rating of the resistor, so the resistor would likely burn up. When you're combining resistors in series to create larger resistance values, I always recommend using resistors with the same value, if possible, to meet your target resistance, because that keeps things as simple as possible.